transformation of heat. So third lesson, transformation of heat. So three distinct methods heat transferred, that is one is the conduction, second one convection, third one radiation. So now we will discuss conduction. So conduction, so heat transferred without moving of the particles in the medium, that is called conduction. Without moving of the particles in the medium, that is called conduction. Okay, it takes place only metals and solids have free electrons. So electrons do not move. The heat transfer from one place to another place, that is called conduction. So consider L is the length of the rod. So L is the length of rod, area of cross section A, and the temperature ends theta1, theta2. So heat transfer from one end to another end. So Q is proportional to theta1 minus theta2. So Q is proportional to theta2 minus theta1. So Q is proportional to area of cross section. Q is proportional to flow of time. So Q is proportional to, directly proportional to length of conductor. So Q is proportional to A T into theta1 minus theta2 by L, or theta1 minus theta2. Q is proportional to AT. So Q is proportional to theta1 minus theta2 into AT by L. So Q is proportional to K into theta1 minus theta2 into AT by L. K is the coefficient of thermal conductivity. K is the coefficient of, K represent coefficient of thermal conductivity. Coefficient of thermal conductivity. So next one, coefficient of thermal conductivity. K is equal to coefficient of thermal conductivity. Coefficient of thermal conductivity K. So here K is equal to QL by theta1 minus theta2 into A into T. So Q into L by A into T. So it is defined, coefficient of thermal conductivity is defined, flow of heat per unit mass, per unit area, and temperature, unit temperature gradient at steady state. K define flow of heat flow, unit area and unit temperature gradient at steady state. That is called coefficient of thermal conductivity. K units, SI unit, joule and meter by Kelvin and meter square and second. So meter cancel, joule by second watt, Kelvin inverse, watt meter inverse and Kelvin inverse. That is a SI unit. And CGS unit, so calorie centimeter by degree centigrade and centimeter square and second. Centimeter cancel, calorie degree centigrade inverse, meter inverse and second inverse. that is K CG students, K dimension formula. So ml square T minus 2 into L by K into L square into time T. So L cancel, M L square, M L cube, L into L cube, and T minus 3 and K minus 1. K minus 1, M L cube, T minus 3. Here T minus 3. Here L square cancel. Sorry, here L square cancel. M L. Here L square cancel. M L T minus 3, K minus 1. K depend on the nature of substance. K depend on nature of substance. K independent in length, area, and rising temperature. So in perfect conductors, K infinite. Perfect conductors, K infinite. Insulators, K 0. Perfect insulator, K 0. K 0. So good conductors and good conductors, heat transfer. Okay, that is a coefficient of thermal conductivity. Temperature gradient. Temperature gradient. Temperature gradient. So theta 1 by theta 2 by T, that is called by length. Sorry, length. Theta 1 by theta 2 by length, that is called temperature gradient. So rising temperature per unit length, that is called temperature gradient. So rising temperature per unit length, that is called temperature gradient. Next, thermal resistance. Thermal resistance. Thermal resistance R. So here Q is equal to Ka into theta 1 minus theta 2 into T by L. So here Q by T equal to Ka into theta 1 minus theta 2 by L. So Q by T, that is equal to power. The rate of heat flow, that is called power. The rate of heat flow, that is called power. So here Ka by L into delta T. So P is equal to 1 by R into delta T. So R is equal to L by Ka. L by Ka. So resistance, thermal resistance formula L by Ka. So length of L is the length of the conductor, K is the thermal coefficient of thermal conductor, and A is the area of cross section. So R is equal to L by Ka. So R is equal to L by Ka is the thermal resistance. Okay. Next, video diffusivity and series and parallel.